libhal ecosystem meeting slides. It is August 10th, 2022. All right, so a TLDR for some of the highlights. We're going to do a progress report. We're going to go over iteration 9. A lot of great progress on iteration 9. Just going to say that off the bat. I'm going to welcome all of you guys to libhal and why we got to that name. I'm also going to go over boost leaf shorthand aliases. I think you guys are going to really like those. How error and how that works and why you need to be using that versus using boost leaf new error. Config type. We added a new configuration called float type, and I'll go into that as well as also the float underscore t, which is also represents float type, and when you should be using that. Last part, the second to last part we're going to go over is why developers won't use units. I'm going to talk about that a bit, and also what our solution is for that. And then if we have time, do a little bit of interface review. I think this is a good opportunity to do that. The discussion board has been up there, and me and Davia have been speaking on it, but I think it's good to just kind of look through a couple of these today, see how that works out if we have time. I may start making meetings next week that aren't aligned with our normal bi-weekly meeting, just to go over certain items. So maybe next Wednesday we'll do that. We'll see. Alrighty, so let's begin. So actually, first off, iteration 9. Let's take a little look at iteration 9. Scroll down, already here. So I got a couple of things in, mostly having to do with float type and the new aliases for boost leaf. Liz got an embed probe as well as also minimum speed at I2C. Probe I2C, just to give you guys an idea, that pretty much just confirms that another device can acknowledge. And then minimum speed I2C is a way to distribute out an I2C driver, and it'll record what the lowest speed was to make sure the bus stays at the lowest speed. This is really helpful because the way that we want the paradigm for I2C enabled devices to operate is that they always set the speed to their maximum, and the user can override that using this API or some other type of thing. They build their own. But the idea is with this library, you can pretty much control what speed your I2C bus works out, and ensure that you don't end up going above what certain devices can handle. Sarah got the rest of the unit tests for libx bitset for the bitset library. So that's been awesome. We're going to be working on adding in continuous integration. That's one of the places that hasn't had it, and we have a lot of things that depend on it, so that's going to be our next steps there. Milo did a lot of work for a lot of refactoring work on changing over things from how percent to percentage. We'll go into more detail about that coming up soon. And that's about it. We have a couple items for the following week. To finish up BitBang SPI, I had some things that blocked us on that. Possibly get embed poll in there. The alpha launch interface review is going to be key after we go over the last couple of things we're changing here. And then this one here, I may or may not do this at this time. We'll see. Okay, so let's get back into it. Everyone, welcome to libhal. Say goodbye to lib embedded hal, that 3-syllable lib embedded. So embedded, so it's 3 more. Hal, so that's like 5 syllables. Welcome to libhal. 2 syllables, easy, short, to the point. So a couple of changes that you need to look out for. One is that the namespace for the entire project used to be embed, now it's hal. Same thing with macros. We don't have that many macros, but if we were to have more macros, you'd replace the embed underscore with hal underscore. Now the why, short, sweet, and to the point. But the full actual story is that I was going to basically make a shorthand for the boost leaf result. Boost leaf check macro. So I was going to replace it with embed check. That was too long, and then I kind of swapped out with hal, just make it see a little bit different. I was like, ooh, that's kind of nice. Only 3 letters, feels more compact. It doesn't feel as intense in length. The only problem is that it felt kind of weird because it didn't conform to the rest of the namespace. So I moved it. I moved everything over to hal to see what it looked like, and I actually really liked how it looked. And that's when I decided, you know what? I'm on a train. I'm doing other work. Let's go put this out to the rest of the team, see what they thought. And pretty much universally, everyone voted yes for that change, not just for the library, but also for the namespacing and for the macros. Overall, hal is the name for everything. And I think it actually looks a lot nicer. Looking at like embedded PWM, hal PWM, hardware abstraction layer PWM, I think it makes sense. Embedded systems PWM, makes sense too, but I think hal really just sells it. And being only 3 letters is Beautiful. Chef's kiss. All right. Make sure I'm recording. I am. Cool. All right. Now, the boost leaf shorthand aliases. So, I was already changing over and masking over boost leaf check. And after that point, I was like, okay, if I'm going to alias this to make this one shorter, and I'm actually trying to remember why I felt the need to alias it. There's something about something that I was preparing for. I think I have some other slides that'll get me to that point. But the main thing here is that after aliasing boost leaf check, it felt kind of strange not have everything else under the HAL umbrella. And even if it's just an alias, at least, it's shorthand. And obviously, because it's a boost library, it needs to start with boost. Next item needs to be its particular project name. So, but the actual developer of the project said, yeah, you should probably just shorthand it for your own needs. So that's what we did. So it should make everything shorter. So for example, when you do result T, and T is actually some value that's non-void, it should be now HAL result T. If it's result void, meaning it doesn't return any status or any variables back, you should just return back status. I think rather than having result void and result T be separated, giving HAL its own status as well as result its own thing, even if the same type, well, not exactly the same type, but they're using the same infrastructure, I think having HAL status be separated really makes it a lot cleaner to look at the code. And now we have now moved from having new boost leaf new error to HAL new error. The bigger one is try handle sum and attempt, and try handle all and attempt all. So I can't use the word try because it's a keyword in C++. So I thought to myself, what's another good way to explain that? And I was like, attempt. And I think try handle sum, it makes sense because you're going to handle some of the errors, but not all of them. But I will say, though, I feel like just calling it an attempt seems better, and it may also return an error, whereas attempt all is attempting all possible errors that can come out from this, or attempt all possible operations, attempt all error handling options. So that's the big difference between these two. Now, why did I do this? Well, short, sweet, and well, actually, the real reason for this is in libhal PR 266. I basically removed the stack tracing code from the code base, along with a lot of other things. I don't think it was not in this PR, but I basically was in this mood of we really shouldn't have any sort of global state because now we have to start considering how do we manage it. Specifically, do we use atomics to make sure that, when you try to change the global allocator or the global stack tracing system or the global logging system or whatever we're doing, there's a lot of things you have to consider when it comes to having that code be available on which platform you have it on and what operating system they're also using. So I relinquished all that code and pretty much tell the user they need to supply it themselves. We can have libraries that do it for them for certain architectures. For example, I don't see why we couldn't have unwinding table or stack tracing type capabilities in libarm Cortex. We can push that off to those libraries versus putting that into libhal. So in terms of error handling, getting environment information such as stack traces among the other operations that are required to be performed. I misspelled that quite a bit. I'm gonna have to go back in there and change that. They need to be performed at the call site rather than at the higher scope. The idea here is that there's very few times when you should run a handler at a lower scope. Usually you need to bring it up to a higher scope where more code is available and visible, more libraries are visible, and you may be able to do certain things like tell the watchdog to reset the system, or reconfigure a particular device in configuration options that are not available in the interface. Things like that. You may need to do some other things that may not be possible at that lower scope. But there's one thing you cannot do at a higher scope, and that is get a stack trace of where you came from without just being there and doing that at that time. I talked to the maintainer and developer of Boost Leaf, and they basically rejected the idea because, we both are in agreement on this, is that it required a dynamic check to confirm that basically if you wanted to put some type of callback at the top layer and then have the new error call that callback first and then set up all your variables or vice versa, there's a lot of issues that come from that. Or I would say an issue. It really just comes down to you can make it work, but you're going to need to do a really costly dynamic check. And this would require the type system to be available, I believe. And if it's not required, I think it's just the fact that you have this additional error transfer latency is a problem. All right, so the only real approach that kept Boost Leaf as fast as possible, but also gave us the capability and option to bring in our own handler when errors occur is, this is basically explaining the same thing. Basically need to wrap over Boost Leaf new error and put our own little code in there to enable or disable a callback when errors occur. And that callback should probably just do a stack trace or whatever it wants to do, maybe log. To keep these things transparent, the code base used the Boost libraries directly, but now that there's a hint of opacity, I realized that the rest of the code should look a lot better with shorthands. This is just me explaining why we have shorthands like this. Once I added one little bit of opacity, kind of started covering things up, might as well do it for the rest to make everything else shorter. And also make things consistent. Now, how new error looks like this, it's very basic. New error takes a whole a whole list of items. We just forward those over to new error. It handles the rest of the actual hard lifting or heavy lifting. We have a constant expression configuration option in the tweak file that allows you to turn off and on if you want to have callbacks enabled. And if you do want to have this on error callback enabled, you can also, that'll then ensure that the on error callback will be called. If you don't define that, it'll just throw you an error saying, hey, we couldn't find this thing. There are only real things you probably want to do here are log at your current state if that's useful information, like where the stack currently is and the PC and that kind of stuff. You can execute a stack trace and log it, or you can execute a stack trace and store it. Maybe store it there's some global buffer that you put your stack traces into, or a thread like a thread local buffer that you can store your stack trace into. So when you get to a higher scope, you can output that information from there, rather than doing it at the low level, because that may be costly in terms of time. And yeah, as you can see here, we also don't pass any of the errors into the callback. The main reason for this is that, one, you're doing a double copy of those items, and to me, it just seems... There's a couple things with this. One, it adds complexity into on error callback. It needs to now take like a template parameter pack and then depack that. I think in a lot of cases we're not really going to want to use that. You also, by passing this stuff over, even by references, you're having to pack in quite a few different items into this call. So there's going to be more copies. There's going to be more data moving over. The latency is going to increase. There's cost to this. There's performance cost to this. And also, it's going to be kind of difficult for a developer to know how to really unpack that information in there. They kind of have to know. They can add something in there that can unpack stuff in there, but I think for the most part, we should not really allow for that for a variety of reasons. I think it's going to add more complexity and give another vector for people to do really obscure things within their error callbacks. And if people say that they need it in the future, then we can totally discuss that with them and look at their situation and see why it makes sense and then open up. I think for now, I think it makes more sense to just kind of keep it contracted, not add too many features to this, move forward from here, see what happens. So that is how new error. Oh, and if you guys have any questions, you guys can always unmute and just say, hey, I have a question here. Okay. All right. Config float type and float underscore T. Okay, so the idea here is to have a universal float type for your application. If you set config float type equal to float, then all places where you see float type will be float. It's just a type alias. The choice of float or double depends on the needs and resources of the application. So I've been thinking for a while on whether or not we should default the entire project to just using float, which is what I did for SJC Dev 2. I've been thinking about whether or not we should just go for double so we can get the maximum power precision and just tell people to get the most expensive MCU. That's obviously not one of my choices that I really thought too hard about. But I was trying to figure out, and even before this, I was trying to get rid of floats and doubles altogether. None of them. But now that I see that we need to kind of use them, and they're actually quite useful and really performant, better than long-ranged fixed point, here's certain situations in which people would change these up. So need speed, but doesn't have an FPU. Float's a good choice, just because it's going to be faster than double. If you need precision and the MCU is fast enough to calculate doubles without an FPU, use double. So If you just have a fast enough MCU, you need precision. Doesn't have an FPU though, use double. If you have an FPU with double floating point, then you should just use double. You have the hardware. You might as well accelerate it up to that. If you have a single precision FPU and you need the operation to be as fast as possible, use float. So these are a couple of situations in which a particular user would choose one or the other. Interfaces that use floats will be templated to allow users to choose which float they want to use, defaulting to config float type. This is still, I'm going to talk about how this may actually change. I'm still thinking about this. I'm still deciding whether or not this is the right choice going forward, but I'll continue on. Implementations of this interface must ensure that the template float type is used for all floating point computations. So if you're an ADC and you're supposed to be using float, you're not allowed to use, let's say float type is a float, a 32-bit float. You're not allowed to use, you should not be using double, because we want to make sure that our operations are as fast as they possibly can be, or basically abide by what the user has told us to do. This allows application developers to to choose which float a driver must use and have control over the precision and computation speed of that driver. There might be situations in which you have probably not a PWM driver, but you may have like a servo driver or simply just an accelerometer where you want that has a lot of detail. Let's say, I've never seen these before, but let's just throw this out there: 32-bit accelerometer, which is an intense amount of precision. Let's say you had one. I think those may actually exist. Well, the thing is, with floats, you can't hold the entire precision inside of the float. It only has 24 bits of numeric precision. So that last set of bits are going to have to be thrown away. So you might as well have just gone with the 24-bit accelerometer at that point, because you're not getting anything better unless it has some other features that you're looking for. With double, you can hold the entire precision and more in that double, since it has 54 bits of precision. So in that case, you'd want your accelerometer class to be templated for double, even though you may not have a DPU. If you want that particular area to be as precise as possible, you can set that up to use double specifically. That is the idea, is to be able to allow the user, the developer, to have that kind of control, that knob. We're going to try to see if we can keep the templates as only to the minimum necessary, and I'm hoping not to actually extend it any beyond this, because I would not like that, honestly. But we can also just do config float type for everyone and not let people get that option. Still considering whether or not which one's better. I will note that it does make the code less consistent, more verbose, and thus a little bit more ugly. I can show you what that looks like right here. So I'm going to zoom in a little bit. And you're going to see here that we have standard floating point here, and then that's equal to config type. It defaults to whatever type you are using. Some of this verbiage here is actually incorrect, since this no longer is %. So we're still working on getting Doxygen to actually work appropriately. Extract all seems to be some issues. We'll talk about that later. Probably another meeting. All right. So we have percentage and we have the float type for percentage. This will ensure that if you have a higher precision floating point type, you can get that with percentage here. And yeah, and the main thing is that you have this little template argument here. If you're wondering, I just want to make sure this is very clear. Yes, if you have an ADC that's float and you have one ADC that's double, you pay for 2 vtables. For every permutation of this template, you hit another vtable in there. So there's an added cost for mixing and matching. But again, if you need that precision and you have the speed and you have the space for having both vtables in there, which you may, in most cases, probably be there, it's not that big of a deal. Especially because this vtable only has 1 entry. So you pay, on GCC at least, using the standard vtable layout, you pay 3 pointers. So 3 times 4, 12. You pay 12 bytes. Then you pay for another 12 bytes if you do the double version. Oh, and I added this in here. I found this. This is not super duper important, but if you're still thinking maybe we can make that fixed point 64-bit stuff work, this particular document or mailing list item or just email is really what kind of, whoopsie daisy. Let's get that back. Click on this. Cool. All right. So here, I just kind of span through here, seeing what type of operations, how much they cost in terms of cycles. You can see a whole variety of them. This is long multiplication, which derives from this 24 cycles. Okay. We can go down here and see like a couple cycles for some conversion from unsigned long to float, and you see some stuff here. You can see division, how long that takes for a floating point to occur. About 76 operations, and these are kind of some extras here. 356 cycles. That's quite a bit. And then you hit the Goliath that is doing division for unsigned 64 bits. And since it has to do long division, it can get up to this depending on how big the number is. So I kept looking back at this to kind of reconfirm that this is just not very helpful. It's more cycles than I anticipated. So, all right, so that's that. So this last part here, let's make sure I check out this. Okay, cool. So last part here is talking about why developers won't use units. And I already removed MP units, but it came back when I started thinking about development for frequency, because I knew that as I did any more work with it, its type is going to have to change dramatically if we do go and use a units library, or if we do something different, which right now, just so you guys know, we're doing something different. But here's the thing. I always observed that we never really used the units library. To be even more specific, there was a time when I realized, I was on Twitter, I was talking with some of the C and C++ committee member, or people who write papers for them and develop for that whole thing. And I had quite a few people tell me that like using std byte is a bad idea. It may look cleaner, but it's basically a non-useful uint8 type. Mainly because you can't do easy operations on it. You can't use numeric literals in order to modify it. If you want to do and or a logical and or not XOR those type of operations, you need to actually create another std byte and then do those operations on them, which ends up making your code way more verbose. And that's when I realized, what do we get out of this? We had more verbosity. We have this name here, std byte, to make sure it's very clear this thing's a byte, but all it does is make our lives harder. What I really want is a hell byte that's uint8. And that's what I did. I switched that out because I just felt annoyed by it. I want to be able to do operations on it. I don't think the code's any more or less safe by using uint8 or using std byte. So honestly, it's just more restrictive without any real benefit besides looking like his name is byte. So I threw that out. Then I started targeting units, and I started realizing that it's kind of the same way. So rather than try to figure out how to make units that people will adopt, I want to ask more just why people didn't want to adopt them. And I've noticed that in every project I've attempted to introduce units into, it comes with friction, non-adoption, workarounds, or removal. Students and other members of the team, as well as myself, have found it quite annoying to work with. And but we also, I want to say this, I think everyone, once you hear about the units library, finds it quite obvious why they are helpful. We all think that having a units library is pretty useful. I even talked to a couple other members before this meeting just to kind of get their point of view. Like, oh, it was cool. I like that idea. And they're like, yeah, I think I might have used them a little bit. And I was like, actually, you didn't, because I looked back at that person's code, asked them, how they feel about the units library, and they said it seemed cool. I look at the code; they actually extracted out the floats out of the units directly in order to do their math. They weren't really using the units library. They were more just we were kind of using them as containers, popping the information out, doing our math in an unsafe way, and then packaging it back into another set of units. And then when I saw that, I was like, what if I just do that? And I'll get into that in a sec. Just so you guys know, the quotes down here come from this paper. I'm so happy this paper exists. 2020, someone decided to look into units of measurement libraries, their popularity and suitability. And this literally explains in detail all of the feelings we've been having about them. Specifically, you can see quotes by people saying, where are we? This picture goes really hard to go into a lot of detail. Okay, come on. Yeah, so lack of concern, indifference, or let's go for another one. No gain in use case, narrow requirements. People either don't really feel immediate need to have something like this, or they don't realize that there's a unit library out there. Let's go around. A lack of adoption factors. Let's see, unawareness. Let's skip over that one. Lack of familiarity. Tradition, not invested. We have our own library, custom solution. We only use std chrono. And then I think the more important part is that like investment of effort required to use a library, just in general, but also adding a unit of measurement framework would add a extra intellectual encumbrance, sorry, that is in the end would likely cause more bugs than it would help prevent. And that part really hit me pretty hard. That's what I was looking for. It is harder to think about. I remember trying to create new types with MP units, unfortunately, and it was really difficult and complicated to look at. I understood it, but it was not easy to understand. And eventually, other people who were working with it could understand it. It just felt really cryptic and weird. And then even just creating the objects themselves felt kind of cryptic and weird as well. And I felt like it would possibly just introduce some actual bugs. It hasn't, I don't know if it has at this point, but there was a feeling that it could. So that's something that I want to talk about, bring up there. There's actually one other item that I wanted to bring up, which is the fact that I'm not saying that this is the wrong way to go about developing this, but I did look at MP Units' conversation or discussion regarding how to handle degrees, specifically discussion on pi. And I was among the people who wanted to make pi unity. There's a lot of, I'm pretty sure anyone who's really into math would listen to this and think that's stupid. But basically I want to just have a version of pi that like whenever you try to convert the value into something that's a string or something like that, you would then apply pi up to the precision that we have for floating point numbers, whatever representation you have, like float or double or long double, that kind of thing. But they decided to go with this kind of prime factorization system. And my fear is that the template instantiation length for that is going to be so large that it's actually going to be confusing to even deduce when it comes to your code. So because of that, I kind of had to I felt like it was time to back off. Now, the conclusion of that particular paper, why we don't adopt units, is because they're, however, units of measurement are hard to define, cumbersome syntactically, costing developer time to annotate, and expensive dynamically. Just to be clear on that, expensive dynamically, I'm not sure exactly what they mean, but I think it's because if you try to do units at runtime, not using some sort of compile time mechanism to handle it, it can be quite expensive to actually do all the operations. Whereas if you just did it with math and knew what the context of those variables were, it'd be more efficient. But even if you get rid of that, the other parts I think are really important. They do not interact well with the ecosystem, have performance issues, and require effort to learn and costly rewrites to support, which would be what we have to deal with. We'd have to refactor a lot of things to make that happen. And the units of measure libraries are best suited for runtime checking where performance is not key condition, but robustness is. This comes from quite a few of the other people's comments in this discussion. So, yeah, that's their suggestion. The last part here, and it was in a different paper that's similar to this. Well, the link here gets you to the full paper. When I was looking at was a shortened, seemed more condensed version. Or maybe it was like an early version. I'm not sure. But I remember reading a part in there that discussed specifically. I'm trying to remember what it was. Specifically that the only places that they saw great adoption was in languages that already have it built in as a feature, such as F#, which is a variant. It's a shortened, more safer variant of C#. Seems to have good use there. Otherwise, it's not really well adopted. And I think if the C++ standard brings it in, and if I can be helpful in that area to try to push them towards something that looks cleaner, I think we'll be in a better position. But until then, we will do what we're going to do. What I'm going to talk about next. So what's the plan for units? Just use floats. Being honest here, just using floats. We can give them type aliases so they have some context, at least when you look at them in the code. This comes back from stdbyte. Stdbyte's not helpful. Stdbyte is actually annoying. But it is nice to see something that says byte next to it. Oh, these are a set of bytes. Not just a UN8. I'm just giving it a whole set of numbers that are, 0 to 255. I'm literally talking about bytes here. Same thing with when we put in hertz, meters, g-force. Now we just have aliases for config float type for each one of these, backing them. Not only that, but there's no reason why we couldn't have user-defined literals as well. You do 100 underscore megahertz, and it should just be 100 million. Yes, there's no particular type behind it. I get that. But at least when you read the code, it'll be quite obvious what you're trying to talk about. And if you go, oh, hey, there's meters, there's length being measured between frequencies, that's probably not the right code. So at least from the readability standpoint, it's easier for you to deduce and find, sorry, not deduce, deduce that there are errors and find typos when you spot them as you look through the code. Backing by config, and I forgot one of those bullet points, but conversions. There's no reason why we can't have conversions. I meant to put an underscore here for 1.5 underscore inch. That's kind of the idea here. So from inches, which is, let's say, a function that we generate, 1.5, it'll convert 1.5 inches into meters. If you do 1.5 underscore inches, it'll convert that into 1.5 inches, convert over to meters in float type. So we can add in a lot of the appearances of the units library without having the restriction between not allowing you to, divide hertz by meters, because there's not a representation of what that would mean for our library. You can divide those if you want. Hopefully divide things that make sense. But we don't have to really worry about the type system basically yelling at us. And I believe the aliases will pop up in showing, hey, alias equals config float type equals to float. So it should look a lot cleaner and be a lot less error message bloat. So that's pretty much the game plan. I feel pretty strongly about this one, and yeah, the next one here is the interface review. Anyone have any comments, questions, or concerns about going this route? Anyone dissenting against this? Any people saying yes, we should do it this way? I'm going to take that as a no. Everyone likes it. Actually, just anyone tell me, does anyone like this approach? Anyone think this is a good approach? Am I still online?
Considering,
Like
yeah, sorry,
Okay.
I was looking for the unmute. Yeah, I think considering the conversation that we've had, I can't think of a better way. And by that I mean I would like to be able to think of a better way, but I can't.
There was
Because
go on.
it would be like so. The standard library chrono literals, it gives it a way of handling, and yes, in some cases you need to do an explicit duration cast, and in some cases you can't, and you explained to me the distinction there before, but the ability to not mix up, milliseconds with microseconds, like you wouldn't accidentally add milliseconds to microseconds without the compiler yelling at you or an implicit conversion taking place, is nice.
Yeah, my hope. Oh, go on.
Yeah, sorry, I was just trying to say, so using your way, if we use some sort of, macro, just for readability, if you can also include a way to enforce compilation errors if somebody tries to add, I don't know, like pounds to kilograms, that would be helpful. I mean, if
Well, no, that should never give a compile error, even with other Unix libraries. That should always work, just like it works in Chrono. Because the thing is, like
Chrono, if you try to add milliseconds to microseconds, okay, if you try to add, the compiler should yell at you if you try to add, kilograms to grams. Forget pounds for a second. Grams to kilograms. The Chrono one will actually either do an implicit conversion or will have a problem with the addition without an explicit duration cast.
So I think within the same dimension, like adding any type to each other, especially if you're using floating point, should be totally valid. And actually, that's what happens when you use if you have the backing for chrono. Then all of the limits behind being able to like, so if you had milliseconds, you try to add microseconds to it, that would air out on you because it would lose precision. You wouldn't actually add anything. If you
Yeah,
add
because
milliseconds to microseconds and store that inside microseconds, then that would work because it would just be 1,000 times whatever your number is.
right. So
Yeah.
it would do the conversion, or it will yell at you for not doing an explicit duration cast, thus maintaining the fact that hey, this is millisecond, this is microsecond.
It will only
Like,
do that if you're using integers. If you use float, it does not warn you. It does not require you to use duration cast.
but numerically, it will do the right thing.
Yes. Also note that like you couldn't add microseconds. You couldn't add microseconds to a milliseconds and do a duration cast. It would always result in 0 unless that number of microseconds was greater than 1,000. So for the most part, basically, duration cast should almost I would say this should almost never be utilized unless you're just trying to shave off bits or like numbers that you don't really need anymore. But I think that like there should always be a conversion whenever you're trying to like let's say take meters and let's say add inches. That should always kind of result in a conversion. And that's pretty much what's going to happen here. So like if you try to create 1.5 inches, that actually generates that automatically does the conversion for you. If you do 1.5, add that into meters, that just adds into meters.
Okay, I see your point.
Yeah. So and the thing is like because the thing is if you're trying to store kilograms or whatever the base unit is, you should be able to add whatever you want. That's kind of the beauty of it is that like you don't have to care about 5 pounds. I gotta do a cast to make sure that it gets over. That should all be seamless because once you start adding in those barriers, it gets repulsively annoying to have to litter your entire code with static casts or other types of cast systems all over the place. So that's one reason why we're doing this. Now you actually brought up one point, which is there a way to maybe like have an error between like I think maybe the other thing you might have been thinking about this was if I add kilometers to frequency, that seems like it should obviously air out on you. And I have been thinking about one idea, which is to put a wrapper around the float type. You basically have a class that does everything float does. It only difference is that you give it a type name identifier of sorts. And whenever you try to add two things of that type together, you get an error. But otherwise, you can add floats directly into that number. You can add like length type things into that thing. Division is allowed between units. That part is not ignored. That part will just kind of result in a float in the end, and you can pass it into anything else you want because we're not trying to make a very sophisticated unit system like the other ones because it incurs compile time. It also increases compile time. That's one of the big things that a lot of these units libraries do is that they take a while to compile. Yeah, that's pretty much the thing. So like addition and subtraction would be the one area that would really benefit from that. You would not be allowed to do you would not be allowed to do addition and subtraction between different dimensions, between weight or mass and time or something else like that. So I was considering that, but I'm gonna kind of hold off on adding in that extra stuff until we need it, because at that point we can actually still modify what the units are without causing any breaks in the API or any breaks in anyone's code. So I'm holding that in my back pocket, and I may pull that out at some later time if I think we need it. Any other questions, comments, concerns? Because that was good. Thank you very much, Samir.
Is there ever a point where this could be integrated later if we changed our minds, or is this like the fork in the road where this needs to be made now?
Oh, you're talking about like if we wanted to integrate units?
Yeah.
So we're not at the fork in the road yet. I think before when we go like on our major launch and actually start pitching this to people, that's when we're going to be pretty hard set to try to move anything around. We could technically always have a big, large change to the code base and then basically have, oh, you're using version 1.0, you need to update all of your drivers to the new 2.0 version that uses the real units library. But so we can change it over. It's going to be um, it's going to be a lot of effort, honestly. Obviously, it's always better to do it right for the first time, so you don't have to come back and make changes. But this one will be pretty drastic.
You had mentioned that some people in C# were really using units as opposed to floats.
They were using, it's an F#, and they were using units. The units backing was floats anyway. But yeah, those are the only group that found success using units. And the reason why is because it's built into the language.
Got it. So we wouldn't have to support that at all. It's just integrated to what they're using.
Yeah. So I mean, if we were using F#, yes, that'd be the situation.
Got it. Okay.
Yeah. Everywhere else though, C++, Java, Java's awful. Python, C#. What was the other ones? I think they also looked at C as well. I think they looked at a couple other ones. We looked at all of those, and obviously C can't handle doing any unit stuff. It would just basically be what we're doing here. Its type system is a little too weak for it to do. Can't really do automatic conversions, period. So you don't get that benefit. Not really useful there. Java makes everything verbose, so also using no units is verbose, even compared to like other languages. So yeah. Any other questions or comments? Alrighty. Now on to the interface review. If you have time, we have 15-ish minutes. So I just put this here as a placeholder so we can add some notes here. So I'm going to just do that. All right, so let's go over to, let's get rid of this, go here. Actually, we're at the spot. We're going to ignore the template part. That part is still in debate. Oh, before I go any further into this thing here, I'm still deciding on whether or not the global, this should be a configuration, or if we should just kind of verify, am I still online? Hello?
Yeah.
Okay, cool. I wasn't sure if that was me dropping off. Okay. Alrighty, so I'm still deciding if I want to keep this here or if I just want to make this equal to config float. And you just don't get that option for your code. But obviously, I think having the ability to control that can have some utility, but I'm still thinking of whether or not that's something that we should, that's something we should do. Okay. Oh, and one last thing to add in before we get started on this. I'm also considering the idea of calling this ADC interface for two reasons. One, to then be able to create the concept called ADC. So, we actually won't go with that. I won't go there. But basically, there's a thing called concepts, and I'm thinking about using concepts to also represent our interfaces. And also, if we call this thing interface, we can also just create an ADC that's already predefined with these variables set for float types. You don't have to worry about putting in the template parameter each time. And if you're thinking to yourself, well, you shouldn't have to. Well, there's one thing. You do at times have to do this. ADC, chevrons, and then reference blah is equal to blah. So that's kind of gross. So we can eliminate that. That would be great. So I'm going to look into there's clean ways to do that, and I'll see if we can keep the name here ADC. But there might be some changes to the interface names coming up soon. Okay, let's move on. So here, ADC just has one function. That is it. It simply just does read. It just calls it a driver read, which is this virtual function here. Returns back a percentage. The percentage type is a float type. I don't know if we actually talked about that last time, but basically it's like %, except it ensures that the output is clamped to -1 to 1. That's pretty much it. As far as we're all concerned, that's pretty much just a float. Yeah, so the return type for this thing is just going to be is a float type from -1, 0 to 1. Just to speak about some other options here, SJCDev2 had returned back a value and then also had a way to return back the maximum value, the full scale value for the ADC. That got rid of the need to do any computation. But the thing is, almost always do people need to take those numbers and have them divided by each other in order for them to actually make sense. Otherwise, you can always just kind of look at the numbers directly. But a lot of times, if you're making generic code, you need to know, that number you have relative to its maximum. So that's an option, but that would require another vtable, another element in the vtable. And I think we can get all the information we need by erasing the depth information, by simply returning back a percentage. And the actual operation of doing division is not that slow. So take your number, divide it by the other number, return it as a float. You're done. Any feelings about this particular API for ADC? Everyone think this looks good? No issues? Alrighty. I guess this is going to be a check off for this. I guess I'll call someone out actually before. Samir, how do you feel about this? Does this make sense?
I think Samir had to leave.
Oh, got you. Okay. Who else is online currently? Let's check. So we got here. Matthew, David, any opinions?
Looks fine to me.
Cool. Alrighty. Let's move over to DAC. This one is basically the same thing. I don't know if you guys would have any opinions outside of this, but maybe you guys have some other knowledge. DAC, same thing, just simply percent, and now it's called write. That one's called read, this one's called write. You're outputting a voltage onto a line, so you can put arbitrary voltages there. You pass in a percentage. Whatever the bits for the DAC are, you simply just multiply that by that number, and you get the number you need to put into the register. Simple as that. Any feelings on this? This is the only vtable item. All right, cool. All right, let's move on.
Yep, seems fine to me too.
Awesome. PWM. All right, PWM. Oh, this one's not been moved over. This one has not been moved over to. Oh, that one's not been moved over yet. All right, gotta do that, but we'll get there. Okay, so PWM a little more complicated. So we have a settings object, and I'm just gonna say this right now. I already don't like this settings object. I want to change this API so that we have a frequency function and a duty cycle function. So if we look down here, we just have driver configure, and we have driver duty cycle. In general, if something has a configuration that doesn't get changed very often, we have a configuration function for it. The idea is that you should only be calling configure at the start of when you're using it and never call it afterwards. But frequency is one of those things for PWM that you may want to modulate. Not only that, but you may be calling it quite often. So there's actually no reason to not have it be another API that's as simple to use or has the same idea that you should be able to call it just in line as much as you like to call duty cycle. So this would also be a percentage. This is percent, should be changed. Any feelings on that? So my idea is actually to do this, just convert this into driver frequency, which allows you to set the frequency, and then driver duty cycle allows you to set the duty cycle. Everyone think this is okay? Anything on your side, David? If you're speaking, David, I cannot hear you. I saw you unmute. Okay, maybe your mic's a little messed up. We are at 7:52, so we got a little bit more time. I'm kind of going through some of the easier ones. Oh yeah, he's looking like he's dropping off to come back in. Okay, but Matt, this looks good, right? Looks fun?
Honestly, I lost my attention for a moment, so I don't have an opinion.
Okay, no worries. Anyone else have any opinions on this? David, if you have anything? I still cannot hear you if you are speaking currently. Okay. If you can, maybe you just post it in the bi-weekly chat. I'm actually gonna see if I can jump in real quick. Go to the chat here. Okay. All right. And yes, this is on the main branch. Sorry, I didn't notice these until now. Okay. Okay. Yeah, if you have any opinions, you can drive them up there. I'm gonna move over to what's another good easy one? I can check these off soon. Okay, easy. Because a lot of these are actually okay. Here's one that's easy. Motor. All right, so we got motor here, float type, blah 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 blah. Also, just a single API. You can see the kind of the train of thought here when it comes to the easier ones. The other ones have a lot more options here. So motor, basically you just apply power, and the power is just some value from negative 100% to 100%. You can see from here we have 0%, which just means no power applied. Doesn't mean that the motor won't still move. Just means that you're not applying any power to move it one direction or the other direction. 100% means whatever it means to go full power. That could be a triac over an AC line to a 3-phase or to a single-phase motor. That could be full PWM for a DC motor. That could be full phase separation for a BLDC motor. Whatever you're doing, 50% would be half that power, and negative is the opposite direction. So that's the idea of motor power. This is a way to abstract away information about like velocity or angular velocity, because there's no real way to know that without having not having some type of encoder on top of this motor. Oh, and the assumption here is that this is a motor without an encoder. Or, to say another way, this could also just represent a motor controller. So it doesn't know what motor you're attached to. So it doesn't have information about that. It just knows how to drive its power from 0 to maximum. And whatever that means for the motor is something you have to do with some feedback. Any questions any feelings on this one?
What about switching direction? Oh, that's just
Negative.
going to negative values.
Yeah.
Okay.
Okay. I'm going to go with David, do you have anything to say on this one? Looks good. All right. I think that was the last of the easy ones. I think we have 5 more minutes. Oh, was that on main? Oh, right. Yes, that's true. I think you're right about that. Yes. I think I took... So normally when I do these, I actually take it from the... let's go to main real quick. So yeah, sorry, I didn't recognize that. No worries. You can go off to your other meeting. All right, so yes, thank you for that, David. You're correct. I was not on main, and it's because I normally link to that particular commit so that people can go back and find them. I have to look through this slide deck. All right, so the next one is going to be, I'm going to go with, honestly, I2C. And I might stretch this over a little bit, but I2C only has one function as well. It has a couple things. So we have settings. We can change the clock rate. I do want to keep this as settings here because I feel like there may be other settings that we may be able to change that are generic across I2C devices. So I want to make sure that we have that available. So settings is probably going to stay for configure. Unless you have some gripe with that, or if you think it should be its own function. It's a lot of words here, but basically we just have transaction. So transaction has 4 parameters for it. You have the address, you have the data out, you have the data in, and you have the timeout. The timeout tells you when to end, and if this particular operation has been going for too long. P address is the address of the device you're trying to talk to. P data out is the data you want to send to that device. And then P data in is the data you want to receive back from the device. Note, this is all you need for all operations for I2C, because let's say you just want to, write to this device. Well, you put in the address, you put in some buffer you want to send out. Then for p-data-in, you make that null pointer in size 0, basically an empty span. And the timeout, I'll talk about that in a little bit. But for the most part, you put whatever timeout you want. But for just writing out, that doesn't make any sense. So let's say you want to read from the device. Well, you just do p address, whatever it is. P-data now needs to be a null pointer, so basically an empty span. And then you put in whatever you want for your how much data you want to get back from p-data-in. You have your timeout. And actually, to the back, write operations may need a timeout as well. If you want to do a write then read operation, you just supply p-data-out and p-data-in. And that's pretty much how I2C operates. Now, you may be wondering what the timeout is for. In general, if you have a device that cannot clock stretch, you should always set p-timeout to never expire. I think that's what I call it, never expire. Just because you never have to worry about that. You have full control over the amount of time it takes for this thing to operate. You know how many bytes you're going to send. You know what clock speed you're running at. You know how long it's going to take to get back. It can be slightly non-deterministic, depending on if the other device doesn't acknowledge quick enough. But actually, I take the back. No, it can't be. It actually always has to be. The only time p-timeout should ever be used is if the other device clock stretches. It's the only situation in which you need to worry about a timeout. Who knows? I might be wrong sometime. I might find out that I'm wrong. But for the most part, that's the only time when you should ever really need that. So if you have a device that clock stretches, you'll need to configure what the timeouts are. Otherwise, timeout should always be set to never expires. How do you guys feel about that, this API?
Why do you have a single function that does both read and write rather than having two functions, one read, one write? And what's the benefit of having just one?
Yeah, so almost every time you write an I2C state machine to actually go through all the different steps, you almost always have to set it up to kind of handle everything. So it ends up being just one big old state machine handling all the different parts. You can split them up into separate functions, but it's no more easier for a developer to have them separated. Not only that, though, if you have them separated, you now need to have, so remember, each vtable entry adds cost to the interface. But if you have a write and a read, you need to also have a write then read function. And all three of those are going to be mostly doing the same exact thing. Which is actually the reason why we got rid of that back in the day, because all three of them were doing the same thing, and they all could pretty much be handled by one interface. Now, if you're wondering to yourself, well, I'd want to just do a write operation. I don't want to have to do all this extra stuff here. You don't have to. That's what utilities are for. The utilities here make it simple for you. So if you just want to write, this one's a bit, you just do a write, you pass in your I2C, your address, your data out, and you can also ignore your timeout because this will be handled for you. So this will end up looking like this. Get rid of that, get rid of that. You have some I2C reference, I2C. You would do write, I2C, set of bytes. And, and one last thing is also the address. Yeah, 16. Now I'll do a write operation. Now, you actually can't do this. We don't take initializers like this, but you just put whatever array you have into that object. Into that parameter slot. So if you want to just...
Yeah, that's really cool. The idea of having a utility for write rather than inside the function itself.
Yes.
And again, that write will also work for other peripherals?
Yes, correct. Yes. The idea is that the semantics of write and read and delay, delay, write and read, and then write then read should have the same semantics for everything. To give you an example, I'm actually going to show you SPI's interface SPI. Oh, sorry. SPI interface. Yeah. And then go to util. We're over by 1 minute. Don't worry, we'll finish up here. We have write, read. Then we also have a write then read. And it acts the way you probably think it would act. Basically, a write operation and a read operation right afterwards. You have the same thing inside the utilities for I2C, which is a write then read function at the bottom. So yeah, it should work across all. It should work across all interfaces for which it makes sense. And that's actually one thing about like a lot of interfaces that they may seem kind of terse. And trust me, not all of them have everything in one single function. There are the other interfaces have them separated into multiple functions. Serial is an example of that. Serial is an example of that. But we get everything we need in this one API here. So, given that, how do you guys feel about this interface for I2C?
With utilities as the tool, yeah, I like it.
Cool. Anyone else? Anyone else have any other opinions? David? Cool. Awesome. All right, guys. So we are done for today. Thank you guys for going through this. I'm gonna pretty much mark these off and say these ones are been approved by the team. If you have any other feelings or want to DM me about this kind of stuff, please do that. Let me actually stop the recording real quick.